we're now going to hear, I'm really interested in this one, to hear about Web3 technologies with NAS. So how does Web3 sort of relate to NAS? We're going to hear from Paul Gampe, who's the CTO at Console Connect. So I can welcome you out, Paul.
Good morning.
All right. Thank you.
Thank you, Greg. Good morning, everybody. My name is Paul Gampe, and I'm the Chief Technology Officer for Console Connect. We've heard a lot over the last couple of days about the transformational journey that us as in the carrier community have been on. And having operated a global network as a service for a period of time, I thought I'd change gears, take you in a different direction, and help you understand a little bit about what happens when you actually operate a global NAS. And the use case that we're going to talk through today is about Web3 and how it's applied to our particular network. It's a really good use case because it talks a bit about the distributed autonomous organization that Mark Helpfinger introduced yesterday, and where we think that there's an opportunity for MEF to move beyond just the APIs for quoting, ordering, and provisioning, but also into commercial settlement. So when this opportunity came to us, we really wanted to lean in and learn what we could about what it meant to be part of a Web3 ecosystem. But before I tell you about this story, let's define Web3, because it's a term that's often used and not always well understood. So let me give you our definition, because it relates to how we've seen our network get used. So Web 1, Netscape, late 80s, early 90s. We'll remember the internet back then, moving from Gopher to HTTP and HTML. It was the read era of the internet. You could read content. You could find things. Web 2 is when we started to write onto the internet. Social media, MySpace, Facebook, we started to write content, and the ecosystem that we know very much today is about the Web 2. Web 3 is not just about Bored Apes. It's not just non-fungible tokens. It's about owning your content. And one of the things that we learned when we started to work in this particular instance was that it's about a network as a service being owned by somebody else and how they choose to use your network. And so what we learned is that in this example, a company that we're working with, this is a customer story, it's not a Console Connect story. Syntropy is building a multi-chain data availability layer, providing a decentralized and scalable way to access, retrieve, and interact with real-time historical on-chain data. So we've talked a lot about latency, applications that are sensitive, and one of the things that we've learned is that these blockchain algorithms, trying to form consensus, are very sensitive to latency. It's difficult for Ethereum or Hyperledger or other blockchains to establish consensus if they're unable to synchronize. So Syntropy is trying to solve that problem, and they wanted to be able to work with a network as a service provider that had a global footprint that could help them achieve that outcome for their end customers. AT&T were just talking about B2B2C. This is a B2B2B example. So what they needed to do was build a network that provided extremely low latency. And I'm sure many of you are ex-network engineers or active network engineers, and we all understand the limitations of the border gateway protocol that we operate our networks on today. It's predominantly focused on one attribute: ASN adjacency, distance of path. That isn't an algorithm that affords you the determination of actual latency. So what Syntropy did is they developed a distributed autonomous routing protocol, a directed graph that looked at a variety of attributes that truly determined latency across the network. And to do this, they built a directed graph that captured these attributes, not just of latency, but of throughput, latency, jitter, and congestion. And so it wasn't looking at the underlying network as a provider. So what we did is we participated in this distributed autonomous network, operating a node, actually a variety of nodes. So we have a global edge compute platform that we operate, and we distributed these DARP nodes across our network, and they participated in this platform. And based on the success of delivery of bandwidth across our network, we would have the right to distribute content on behalf of their end users. And it's a distributed ledger technology-based provider, And so we would earn gas. We would earn tokens for our ability to deliver traffic on behalf of participants in the Syntropy platform. We were one of many operators. Cloud providers, the big hyperscalers also were used as participants in this network. So there's a really interesting way to give away your network as a service and see what use cases start to evolve when you're willing to trust these distributed autonomous approaches to operating your network. So we operated 12 nodes around the world, and thankfully we're often chosen to be a very successful provider of connectivity in this network. A way to visualize how it works, though, is this diagram. So what you see here is all the different participants, all the different nodes across the Syntropy network, and the performance attributes of their latency between different points of presence. Really interesting study, not just of internet dynamics, but also of participation in the distributed autonomous routing protocol and their effectiveness in terms of delivering bandwidth. And so the state of the network was distributed across all the nodes on a regular cadence within seconds as a directed graph, and then the best nodes to deliver the path that was requested by the end user was the one that was chosen. And so we got to see what it was like, how we compared our network performance to others, and regularly, thankfully, we were chosen to be the deliverer of the end packet. But what we learned is not just that participating in a network that is sophisticated, attribute-driven, and decentralized wasn't the only thing that we got to learn about being a participant in a Web3 environment. The most important thing that we got to learn was about how they will approach settlement. So yesterday we had Mark Helpfinger on stage, CEO of Console Connect, talking about 2014, 2017, 2019, the journey that PCCW Global and Console Connect has been on with MEF in ensuring that the work that we do as a community is focused on getting to the final outcome of full lifecycle management. And ultimately, the hard part in full lifecycle management is settlement. Many of you are on the journey of exposing, quoting, ordering. Some of you may have achieved provisioning. But we had an opportunity with this particular customer to learn about what does the final full lifecycle mean. And so we were able to participate with them in building out a smart contract, an approach to fully automated settlement, the holy grail that all of us have been trying to achieve over this period of time. So this diagram illustrates the different participants in the approach, and this is live, it's in production, it's how we do settlement with Syntropy. So us and Syntropy establish a partnership and determine what are going to be the attributes that are core to the relationship that we have. And in this particular instance, with Syntropy operating an overlay network, whose primary attributes is its performance, its bandwidth, and its location. So we operate a series of nodes around the world in this DARP protocol, and we've agreed on a set of attributes, so it's location and bandwidth. Once that's been agreed, we then codify that into a smart contract and agree on a file format to capture those attributes. So it's something like a CDR record for a voice call, for example. And then on a regular cadence, in our instance, we agreed on a 30-day settlement terms. We upload our view of the performance of our network. They upload their view of the performance of our network, and we both execute the smart contract. So to give you an example that this is real, it's not just a series of diagrams, wanted to show you this slide here, which is the actual user interface. And what you can see here is the same user interface. Syntropy is our partner, us as the operator of this particular relationship. Both use the same interface. And so we can see here is those attributes that I just described. So it's the location of the node that we're operating. It's the data set that we're uploading. And we also, in this agreement, established tolerance. So you see here that in the smart contract that we execute, we've got an agreement saying that if your view of the data delivery that we achieved and our view of the data delivery that we achieved are within a certain tolerance, then we're going to agree and we'll execute the contract. We could set that to be absolute, we could set it to be a percentage. And so when I talk about working with Web3 partners and what we've learned that the things that we've done in traditional relationships of emailing invoices to each other, tolerance thresholds are part of things that you can codify in a Web3 world. So here's the actual code that we execute in the next example. So you can see here the attributes that I was just describing, the data centers, the dates, the traffic from the SDN network, the traffic from the DART network, and the parameters with which we're willing to accept them. So you can see here the variance attribute that I was describing earlier. And here's the code. So this is the actual code that gets executed when we do settlement with Syntropy for the network performance or the bandwidth we've delivered over a period of time. At the start of the code here, you can see we're just defining the two data sets. So their bandwidth utilization metrics, our bandwidth utilization metrics, the geography within which it occurred, the start and end dates. And then based on those tolerances that we said earlier, we either agree that this is a contract that can be executed and settlement will occur, or we agree that we've entered into dispute and that we need to take this off for a manual process for resolution. In our particular instance, we chose not to participate in Syntropy as GASP receivers. We executed this upon settlement into a fiat currency, not because of any reason that we disagreed with the approach, but simply because establishing a financial relationship with a token is something that our finance team still needed to consider in terms of how do you represent that in our ledger. But certainly there are participants in the Syntropy network who are receiving their economic benefit through the Syntropy token. So if we were a participant receiving tokens, then we would have automatically, at this point, at the conclusion of the contract, received the economic value transfer. So a way to show you about how that's completely decentralized. In that instance, there's actually no humans involved whatsoever. There are API calls that upload the data. Once the data has been uploaded, a smart contract executes, economic values transferred, no human intervention, full life cycle management, the holy grail of what we're trying to achieve through these standards bodies. So in conclusion, what I hope you've taken away from this brief journey into what Web3 is and what it may mean to you and your networks, and thinking through the impact to your organizations and some of the things that we've learned, is that if you make your network programmable, it's globally distributed, it can participate in the API ecosystem, then there are ways that people are going to use your network that you never forecasted or never anticipated. We've heard from AT&T earlier today about unlocking new ways to deliver value, new ways to generate revenue. And certainly from our lived experience, and hopefully the story I've just shared with you, we're really excited about the future, and why Mark Helpfinger yesterday would have talked about distributed autonomous organizations and what are the economic benefits that we as a community can start to achieve if we were to do things like setting up a DAO and setting up ownership and staking and holding some of the intellectual property that's critical to us. All of us are using BSS and OSS systems, but none of us own that intellectual property. We're in a vendor community. But what if we were to collaborate and put that into a shared pool administered by a DAO, and let's set up governance and using tokenization as a way to govern these projects that are really critical to our future and our success. Hope you've appreciated the journey. Thank you for your time.